Hello, welcome everyone to this part where I shall discuss about equation of continuity. See, equation of continuity is nothing but uh, the law of conservation of mass in fluid dynamics. It's nothing different. So we have seen that whenever the fluid is going through a tube for any particular time interval, the total mass of fluid which is going into the tube, which is entering the tube through any cross section, in that particular time interval, for that particular time interval, the same mass of fluid is coming out of any cross section of that tube. So this is what equation of continuity is. It's nothing different. So let me first deduce the formula and let us use the approximation there. So this equation of continuity continuity. Let us say this is a tube, that is a tube, and here I am taking this cross section here and I am taking another, any two random cross section you consider, and this cross section is having, suppose, the area of cross section A1, and here it is having area of cross section A2. So let us consider a time interval delta t. So the time interval I am considering here delta t. So now let us find out how much fluid is going into this tube in delta t time. So how much is that? So let us construct a cylinder of length v1 delta t. What is v1? v1 is the velocity of the fluid which is going into this part of the tube, and v2 is the velocity of the liquid, which is fluid, which is going out of it through this cross section A2. So if I construct a cylinder of length v1 delta t, that is here, suppose this cylinder. So this cylinder is of length v1 delta t. So all the fluid inside this cylinder, inside this much cylinder, inside this cylinder, all the fluids inside it are entering into the tube through this area of cross section in delta t time. So let us find out the mass of the fluid inside this volume first. So how to find this out? So the volume is A1, the length, the area of cross section is A1, and the length is V1 delta T. So this is the volume of the, what is this? This is the volume of the cylinder. Volume of the cylinder of length V1 delta T. And what is this? What is this volume? Volume of the liquid entering the tube in time interval delta t, in time interval delta. This is the volume of the liquid which is entering the through area of cross section A1. So that is the velocity. What is that? A1 V1 delta t. So this is the volume. I am talking about the volume, but need the mass here. So the mass of the liquid entering the area of cross section entering the tube through area of cross section delta A, right? Sorry, not delta A, very sorry, A1 A1 in time delta T is what? Volume into density, definitely. So if I say the density of the fluid is here at rho 1, then the mass is what? Volume into density. So volume is A1 V1 from here, A1 V1 delta T, A1 V1 V1 delta T multiplied by rho 1. So this becomes A1 rho 1 V1 delta T. Same, in the same manner, if I consider a cylinder of A2 cross section, then the amount of fluid which is going out with the speed V2 going out of the tube in time delta T, in the same manner, the mass of the liquid going out of the tube through the cross section A2, right, in time delta T is what? A2 rho 2. Let us say if the density here is rho 2, A2 rho 2 V2 delta T. So this mass will be same. This mass, ingoing mass and outgoing mass, this will be same. So according to the conservation law of mass, A1 rho 1 V1 delta T is equal to A2 rho 2 V2 delta T. So these two will not be cancelling on each other. This part, this delta T and delta T will be cancelling each other out. So what do we get? We get A1 rho 1 V1 is equal to A2 rho 2 V2. So this is what principle of continuity is. But in most of the cases here in this chapter, we shall be considering this consideration. Remember, this consideration is very important. We shall be considering few things. First assumption will be the fluid will be ideal. The fluid is ideal. Ideal means I have said you two properties. One is non-viscous, and the second property it will be incompressible. Incompressible means that is density is constant. Density is constant. And number two, the fluid should be irrotational fluid. There will be no rotational effect. There will be no rotational motion for the fluid. Irrotational fluid. That is, the net angular momentum for any fluid particle will be 0. So that is what we call an irrotational fluid. So for this kind of fluid, for a non-viscous, irrotational, incompressible fluid, the rho 1 is equal to rho 2. So if I impose this considerations or assumption for this general form of equation of continuity, so for this kind of fluid, rho 1 is equal to rho 2. So this equation of continuity becomes A1 rho V1 is equal to A2 rho V2. So these two things will be cancelling each other out. So we shall be getting A1 V1 is equal to A2 V2. So this is the form of equation of continuity. So as you can see that I have derived it from the conservation law of mass, that no mass is being destroyed in between these two area of cross section. So whatever fluid is going in, that same mass of fluid is coming out. So I've derived the equation of continuity from this concept, that is the mass of conservation law of mass. Now, so for an ideal irrotational fluid, the product of the area of cross section and the velocity and the speed remains the same at all points. At all points, I have derived it for the initial point through which the liquid is entering and the final point through which the fluid is going out. But this equation is constant for each and every point inside the tube for a tube flow. Okay, so this is called the equation of continuity. Okay, so let's meet in the next class.